Hello, algebra students. Well, today we're going to look at complex numbers. Well, these arise when we take the square root of a negative number. So considered, for example, the square root of negative 16, like we have here. What do you do with that? So we know 4 times 4 is 16, and a negative 4 times negative 4 is also 16. So what number would be times itself to get negative 16? Can you ever get negative 16 by multiplying the same number by itself? And you can't if you're confining yourself to using real numbers. So imaginary numbers are what you get when you take the square root of a negative number. The other numbers that we use all the time are called real numbers. And by definition, we say the square root of negative 1 equals I. It's called the imaginary unit. And since the square root of negative 1 equals I, if we then square both sides of that, we get that negative 1 equals I squared. Okay? So, that's what we have. That's the tool we have now to deal with the square root of any negative number. We have this number I, which is the square root of negative 1. So let's just see how that works with this first example. We take example 1, we take the square root of negative 16. So we have to write that as inside the radical, we split that into negative 1 times 16. Okay? And then we can split that into two different radicals. And this is how we deal with it, because now we have this square root of negative 1 right here, and we've said, okay, we can deal with that. That is I. Okay, the square root of negative 1 is I. So we simply call it I, and we still have the square root of 16, which is 4. Okay, so we do write that the other way around as 4I. Okay, so we can take the square root of any negative number now. The result is going to have an I in it. You might wonder, what are these imaginary numbers even for? I mean, this is really weird, but they are useful. They started using these pretty much in around the 1500s, I think, and they found they could solve some cubic equations. Those are equations that have something cubed. They have an x cubed in them. It actually was helpful in the solution to introduce this idea of the square root of a negative number. And sometimes the I that they used would cancel out later on as they worked the problem. But just by using it, it would actually help them solve problems. They thought it was really sketchy. They weren't really sure what to make of it. But, they found them useful, and so they did use them. And then over the centuries, they became a lot more commonly used, and people discovered other ways, other things you could do with them. And now imaginary numbers are used all the time in engineering, electrical engineering especially. They don't necessarily cancel out of the equations anymore. You can have an I in those equations, in those mathematical results in electrical engineering, and it's just fine. There's a meaning for them in science and in different fields of science, and they're very useful. So, at first glance, we say, I don't even know what that means, but they are useful. So, let's look at some more examples. The square root of negative 18 is our next one, and we have besides just having the negative to deal with, this time we also have that the 18 can be simplified. The square root of 18 itself can be simplified. So let's look at this. What we're going to do, is take out that square root of negative 1 first. Okay. And we will get our I there. But then we have to see what we can do with the 18. So let's just do this off to the side. And this is like we did yesterday. We divide by 2. Since it's even, that gives us 9. Divide by 3. And we get a 3 there. And we do have a pair of 3's there. So we can pull a 3 out of that, and inside is still the 2, right? So we have that, and the I is still there, of course. So we usually write that, we switch the order around. We call this 3I the square root of 2. So that is simplified. Okay? Now, next example is adding and subtracting complex numbers. So we have a couple of examples here. And complex numbers are numbers that have both a real part and an imaginary part. And these are used all the time as well in real life in science and engineering. So, for example, you could have 5 minus 3i. That's a complex number, okay? And negative 2 plus 4i. That's another complex number. These have a real part, which is the negative 2. That's the real part. And the imaginary part is the 4i. So adding them and subtracting them is straightforward. You simply combine the real part and then the imaginary part. So let's first distribute the negative sign here. We have 5 minus 3i, and we have minus a negative 2. So that's plus 2, and we have minus 4i. So all we did there was distribute that negative sign. And now we can combine the real part. So you have 5 plus 2. That's the reals, right? And so that is 7. And negative 3i minus 4i is negative 7i. And that's all you can do with it. This is a complex number. You cannot do any math at all combining those two parts. The real part cannot be combined with the imaginary part. It's just a complex number, and that's it. Okay? So next one, we're going to just add the real parts, the 3. Well, I'll go ahead and get rid of the parentheses. 3 minus 6i minus 2 plus 2i. And the parentheses just show they're separate numbers. This is the first complex number. This is the second one. But when we do the addition, we add the real parts. So that's 3 minus 2, that's 1. And the imaginary part's negative 6i plus 2i, that's negative 4i. So that results of that one. Now multiplying them is a little more complicated. It's not bad though. We just in this case we have a just imaginary number. It's not complex because it does not have a real part, and we're multiplying it by a complex. Oh, I'm sorry, it's still considered a complex number. I misspoke. But it's this 3i is really could be written 0 plus 3i. Okay, so it's a complex number, but its real part is 0. Okay, so we could say it just has an imaginary part. We might say it that way because, well, the real part is 0. So this is simpler to multiply. We just distribute this like this. And so that gives us 3i times 7 is 21i. And 3i times negative 6i is negative 18i squared. But whenever we multiply these, we start getting these I squared things showing up. And I squared is different. It's not just I anymore, it's I squared. And interestingly enough, we know what I squared is. I squared is negative 1, right? Because that's what I is. I is the square root of negative 1. So when you square that, you get negative 1. Okay, so this is 21i minus 18, but that I squared is negative 1. So that's 21i. And this is plus 18 here, right? It's minus 18 times negative 1, but 18 times negative 1 is negative 18. So minus a negative 18 is plus 18. And that is now the real part of this product. But we write it down by, we switch the order of those. We have 18 plus 21i is the way we write it. And that's it. Okay, so this next one, both numbers have a non-zero real part. So this one has more work to do. So we FOIL it. Okay, just like we would if this was something like, if this was two binomials, x plus 3 times x plus 5 or something like that, we would FOIL it. We do that. So this gives us negative 3. And then that gives us negative 6i. And then we have this, which is negative 6i, it turns out. And then we have this, which is 12i squared. Okay, so we know what's going to happen here. Oh, sorry, that's a negative 12i squared. Because negative 2i. Negative 12i squared. Okay, so let's see what we can simplify the next step. We still have the negative 3 out front. Negative 6i minus 6i, that's just combined to negative 12i. Okay, and then the last term, I'm going to go ahead and write that as negative 12, and I squared is negative 1, right? And so that becomes negative 3 minus 12i. And then we have, again, 12 times negative 1, that's negative 12. So we're subtracting negative 12, so we're adding 12. Okay, so this kind of thing happens all the time. That I squared shows up and you're multiplying by a negative 1. The signs get changed in that manner. So we have negative 3 plus 12. We can combine that, and that makes 9 minus 12i. Okay, that should be correct. Okay, so we have one more thing we need to look at, and that's have to bring up another page. Let's see, page 2, and this is dividing complex numbers. And this looks really big and involved. It's not as bad as it looks. Dividing complex numbers. What we really do is get rid of the denominator, and in that sense we're dividing it and getting the result. The way we do that is we multiply by what's called the conjugate of the denominator. The conjugate of a complex number is the number that we multiply by it to get rid of the imaginary number. Okay, so what we have on the denominator is actually 0 plus 3i. I'm going to write this over here. 0 plus 3i. So the conjugate of that is 0 minus 3i. And we'll see why in a moment. But just for now, just trust me on that. So this in the denominator is actually 0 plus 3i. The conjugate is 0 minus 3i, so that's what we're going to multiply top and bottom, okay, times 0 minus 3i. However, writing out, including the 0 doesn't really help us, so we're just going to write that as negative 3i, okay? But that's just the more useful way of writing something. It really is this if we include the real part. And again, we use that because it's the conjugate of that, which is the denominator. So multiply top and bottom by the complex conjugate of the denominator. That's the rule. I should probably write that down somewhere. How about over here? Multiply the numerator and denominator by the complex conjugate of the denominator. Okay. So let's do this. So in the numerator, we just distribute the negative 3i, okay, to each of those inside. Negative 3i times the 9 gives us negative 27i. Negative 3i times 12i, Okay, that gives you a negative, because it's negative times positive, negative 36, but we have that cool I squared lurking there. So that's the numerator. The denominator, 3i times negative 3i, that's negative 9i squared. Okay, so now let's see what happens. We're going to deal with these I squareds, right? They become negative 1. Negative 27i, and we'll just write this as plus 36. Okay, maybe I sort of left out a step. Let's go ahead and write that this time. We'll leave it minus 36, but times negative 1. Okay, because that's what I squared is. And the denominator, we can deal with that too. That's still negative 9, but it's times negative 1, right? If we don't go ahead and do anything with that negative 1, we'll just write it like this. Okay, so the negative 9 stays the same, and we just wrote I squared as negative 1. Keeping track of the negatives is a little tricky. You have to be really careful with it. So what we'll do in the numerator is just go ahead and simplify that 36. So we have negative 27i, and it's 36 times negative 1, which is negative 36, but it's minus negative 36, so plus 36. And then the denominator is just 9. And now we're almost done, but we might be able to simplify this. And for complex numbers, you don't leave them like this, but we take each of those over the 9. So we have negative 27i over 9, and we have 36 over 9, sorry. Kind of looked like 3b, but... And let's see, I'm going to get rid of this, if I can. That'll give us a little more room. The 36 over 9 is 4. And we write that out front usually. That's the standard way of writing it. So this negative 27 over 9 is 3. So that's just minus 3. And the I is still there. Okay, so that is it. Kind of a funny way to divide, but it does give us a result. Okay, 4 minus 3i. And that's how you divide. So let's look at the next one. Now, the complex conjugate, we're going to see where that comes from now. We have 2 plus 3i over 1 minus 4i. And so we say multiply top and bottom by the complex conjugate of the denominator. So let's just do the drill, and then I think you'll see why this is the way you do it. So you have 1 plus 4i over 1 plus 4i. And that is the complex conjugate of the denominator. So it's pretty simple. It's just, if it was 1 minus 4i, then the conjugate is 1 plus 4i. But if it was 1 plus 4i, the conjugate would be 1 minus 4i. Okay? That's all it is. And over here, so we had 3i positive is in our problem, so that's 0 plus 3i, and the conjugate is then 0 minus 3i, which is what we used here. They just didn't write the 0. Okay, so we've got this. You'll see what happens and why the conjugate is what it is. So we FOIL the top, and we also FOIL the bottom. When we FOIL the top, we get 2 plus 8i plus 3i, and then plus 12i squared. So just when you thought the i's were going away, 12i squared. And that's actually a good thing to see, though, when you see that I squared, because that is an I that's going to go away, because that's just -1. Okay, so now the denominator is the interesting one. We don't want to have I in the denominator. So that's the deal with this conjugate. When you multiply the number by its conjugate, and we chose 1 plus 4i exact because it is the conjugate of the denominator of that fraction. So look what happens. 1 times 1, let's see, I'll do it this way. 1 times 1 is 1. 1 times 4i, should have left a little more room here, is 4i. And then you have negative 4i times 1 is negative 4i. And you have negative 4i times positive 4i, and that's negative 16i squared. Okay, so we see the method to the madness, because we have 4i plus negative 4i. That's actually kind of cool, because now the i's are gone from the denominator and we can simplify what's left. Okay, so the numerator, 2 plus, and we have 8i plus 3i, so that's 11i squared. Okay, plus 12i squared. And we already had the 2 out here. Remember, oh, not 12. Yeah, it is 12. So let's see what we can do with the bottom while we're at it. And let's also, in this step, go ahead and replace this plus 12i squared with negative 12. Why don't we do that? Because 12i squared is negative 12, right? I squared is negative 1. So that's just 12 times negative 1, which is negative 12. So we have this now, and this denominator is pretty nice. The 4 i's cancel. And so there's no i's left, because 16i squared, that i's going to go away. So you have 1 plus no, sorry, let's do it this way. Let's not do too many steps at once. 1 minus 16i squared, but I squared is negative 1. Okay, I think this is a handy way to do it to try to avoid mistakes. Okay, the 4 i's we got rid of. Okay, and we have negative 16, and you could try to do this all in your head at once, but it's just not worth it. I would say, at least until you've worked with these a lot, go ahead and write down your negative sign there. Go ahead and do the drill, and because you're subtracting it, right? And then your I squared, though, is negative 1, and you rewrite it as negative 1. Okay, and then we're getting there. This numerator, we could actually combine that 2 and the negative 12. That's negative 10. And then we have this 11i is still there. Or let's see. Oh, I made a mistake here. I wrote 11i squared. See, if I was in class, you guys would say, that's not right, and I would fix it. Gotta make this small so I can erase. Good. That. Yeah, somebody needed to stop me there. So that comes, of course, from combining this 8i plus 3i. That's 11i, but not 11i squared. So in the top, we said we could combine this 2 minus 12, and that gives us negative 10. But the 11i is still sitting there. We haven't gotten rid of that yet. What's going to happen to it? On the denominator, 1 minus a negative 16, right? Because this 16 times negative 1 is negative 16. So 1 minus negative 16, and that is just 1 plus 16, which is 17, right? So let's go ahead and write that. We could go ahead and put some equal signs here. Okay, so we have negative 10 plus 11i over 17. Because 1 minus negative 16 is 1 plus 16, which is 17. And now we should write this the way they're traditionally written, and there's no reason to buck this attitude. So we split this in to the two fractions. So we have negative 10 over 17, and then we have plus 11 over 17i. Okay? So that's just a matter of writing each of those over that denominator. Splitting it up into two fractions, so to speak. Negative 10 over 17 plus 11i over 17. So that's the major operations that we do on complex numbers. We have dividing them, and then we had above that in the other page multiplying, right? And we had simplifying, okay? Adding them, subtracting, multiplying, dividing, and just simplifying. Okay, so that's it for now, and thanks for watching.